We are in lecture number 13. Yesterday, we discussed. So, in that lab, I explained to you the two basic concepts. The first one is a static routing, and the second one is a dynamic routing. Okay. So, what is routing? What exactly routing means? Sending the packet from one network to another network. Okay. So, from a local area network to the another local area network, you can send the packet. So, that concept is called the routing concept. Now, so in this lecture, we are going to discuss about the few things. The first one is we are going to discuss about the functions of the network layer, the basic functions. So what does network layer is doing? What are the major functions of the network layer? Okay, that means layer 3. Then we are going to discuss about a concept called delivery of packets. Okay, so what is delivery of packets? We are going to discuss. Then routing concepts we are going to discuss, but we already covered this as a lab part. Then classifications of routing protocol. What are the different types of routing protocols available? Okay, we are going to discuss. So this is what we are going to discuss in this particular lecture. Now, I'm going for the first part, the first one, network layer. So network layer is layer 3. Okay, you can see this is the network layer. So in network layer, above the network layer, we are having the transport layer, and below the network layer, we are having the data link layer. Routing. Routing is one of the important concept which is going on in layer 3. Okay, so routing is a very important concept, okay, of layer 3. Okay, in layer 3 only, okay, we are having the routing concept. Now, not only routing, we are having addressing. So addressing means IP addressing. So about this, we already discussed this in the lecture number 1 and 2. Okay, what is IP? I think, sorry, lecture number 5, I think, lecture number 5 or 6. So we discussed about what is IP addressing. Okay, IPv4 addressing we discussed. Then, other than routing and addressing, there are other functions. Okay, there are other functions also. One is fragmenting, packetization, and internetworking. So these are all the things which are going on in the network layer. We can say these are the functions of a network layer. Okay, the functions of the network layer, it is routing, fragmenting, addressing, internetworking, packetization. Okay, these are all the different functions. Then in layer 3, that means in the network layer, there are some protocols. Okay, there are a lot of protocols running. So what is that protocol means? You can see routing protocols. Routing protocols also running in this particular layer. So routing protocol means, okay, yesterday we discussed one routing protocol, that is a RIP protocol. Okay, so we discussed about the RIP protocol. So RIP protocol is running in the layer 3. Then there is a concept called multicasting. Okay, in the next semester you will study about this multicasting. So multicasting also, okay, it is running in the layer 3. Then address resolution. Address resolution means to find the MAC address, finding the MAC address by using IP address. Okay, finding the MAC address by using IP address. So that is called the address resolution. So if you take network layer, there are so many different things are happening in the network layer. Okay, network layer, internetworking, packetization, okay, addressing, routing, fragmenting, address resolution, multicasting, and then routing protocols. So all these things available in network layer. So network layer is a very important layer. Router. Router is the device. Okay, router is the device which run in the network layer. Okay, so where is router used means router is used in the network layer. Okay, now moving on to the next one. The next one is packet delivery. So what is packet delivery? Packet delivery means sending a packet from one network to the another network. Okay, that means the network layer supervise the handling of the packets by underlying the physical networks, that is the delivery of packet. So that means I give you a small diagram. Okay, so this is first network, this is connected with a router, and this is the second network, okay, connected with the router. Then this is the third network. Okay, all these three networks, okay, I'm going to connect like this. This is the topology diagram. Now, I'm going to send a packet from here. Okay, I'm going to send a packet from the first network to the last network. Okay, I want to send this packet. So if you're sending like this, the packet will go to the router first. Then the router will forward the packet to the next router, sorry, next network. Then from here, it will go to the next router. Then it will go to the next router. So who is playing a very important role means routers. So routers are playing a major role, okay, in packet delivery across the networks. Okay, across the network. That means from one network to another network, if you want to send the packet means router is very important. So delivery of packet. So delivery of packet, okay, it will be completely done in the network layer. Then the next concept is there are two different types of delivery. Okay, you can deliver the packets in two different ways. That means in a network, the packets can be delivered in two different ways. One is the direct delivery, and second one is the indirect delivery. Okay, so what is direct delivery? We can see in the next slide. So direct delivery means, okay, you can see the topology diagram inside the network. Inside the network. Okay, this is only one network. So here a host is available. So this person wants to send a data to the next host. Okay, this is inside, completely inside the network. Okay, so this is the first machine. Okay, host A 10.0.0.1. We have done this yesterday in our topology diagram. So we created a network, two networks we created. From one PC to another PC, you can ping. So that is called the direct delivery concept. So you can give the ping command or you can deliver the data from here to here. So this is called direct delivery inside a local area network. You can see from the router, this is our gateway. We discussed about this yesterday. There is a gateway available. So from the gateway, I'm going to deliver a packet to this machine. This is direct delivery. Now, so what is indirect delivery means? You can see this host is available in a separate network and this host is available in a separate network. Okay, they are in a different networks now. Now from this machine, okay, I'm going to forward the packet to the router. I'm going to forward it to the router. So now this is called indirect delivery. Indirect delivery. Then the router is going to forward it to the computer. Okay, from the in this network. This is called direct. Okay, direct delivery. So indirect delivery means the destination. Okay, I'm going to tell technically. Indirect delivery means the host, that means the source and the destination will be in different networks. Source computer and the destination computers will be available in different networks. So this is the case. This is the source. Okay, the first one is the source and the last one is the destination, target. So they are in different networks. So in that case, okay, we are having the indirect delivery, but direct delivery means both they are going to be in the same network. Okay, so this is the concept of indirect and direct delivery. Now, I'm going for the next one. The next one is forwarding. So forwarding means what? What does packet forwarding? So packet forwarding means, okay, you can see, I'm taking a topology diagram. This is a host in a network. This is a router. I'm having one more router. Okay, make one more router. Three routers I'm having. And this is the last, okay, my destination. So they are connected like this. Okay, so they are connected like this. So we have three routers here. So this is router 1. Okay, this is router 2. This is router 3. There are three routers available. How many networks available here? How many networks available means you can see this is one network. Okay, and this is the second network. This is the third network. And then this is the fourth network. So totally there are 4 networks available in this topology diagram. Okay, 4 networks available here. Now, I want to send a packet my source is this. So from here, I want to send a packet to this machine. Okay, this is my target, or I can say this is my destination, and this is my source. So from the source to the destination, I want to send the packet. Now, what is packet forwarding? So packet forwarding means now you can see your packet is going to move from from your machine to the router. Then, so in the router, you are going to have the routing protocols. Okay, you are going to have the routing protocol. Yesterday we discussed about RIP protocol. So you can use the RIP protocol, or you can use a static routing. So in the yesterday lab, we created both. Okay, I don't know how many of you saw that video. I already uploaded the video. Okay, the video is available, and I sent the link also to you. So the source, it is forwarding the packet to the router. Okay, so router you can have anything, either a routing protocol or you can have a static routing. Now the router 1 is going to forward the packet to router 2. This is called forwarding. So what is forwarding means? So simply a host, that means a router, it is going to check in the table. There is a table available here. The name of the table is called routing table. Okay, it will maintain a routing table. So the router will check in the routing table, then it is going to forward it. It is going to forward to the next host. That means to the next router. Then this router is going to check it in the routing table. Then this router will forward. Okay, it will forward the packet to the next router. So forwarding means, okay, it is simply pushing the packets to the next. There. So this person here, it will check in the routing table. Okay, the routing table is available here. Check in the routing table. Then it will forward it to the host. So this concept is called forwarding. So forwarding means to place the packet in its route, Route means path. Okay, in its route to the destination. So here forwarding, and finally it will reach the destination. Okay, so this is the concept of forwarding. Now we are going to see the same concept in a detailed way. Now you can see they are giving an example. They are giving an example. So what is the example means? You see this. This is a host A. It is available in a network connected with router 1. Then from router 1 to router 2, there is a network available, but there is no host. Yesterday we saw this in our topology diagram. Then router 2 to router, okay, that means the next network, host B. Now, how many networks available here? This is one network. So this is the second network. Then this is the third network. Okay, this is the third network. So totally three networks available in this case. Okay, three networks available in this case. Now, in router 1 and router 2, they will maintain a table. They will maintain a table. What is a table means? That is called routing table. You can see routing table, routing table. So for every router, there will be a routing table. The routing table will be available inside. Now, so a host, this person is sending a packet. Okay, he is sending a packet. Okay, this is a packet. So the packet, I want to send it to B. Okay, for this is my destination. I want to send it. Now the packet is coming to the router. The packet is coming to the router. In the router, I'm going to check. That means the routing protocol or the static routing. Okay, it is going to check in the routing table. Okay, this is the table. It will check in the routing table. Now, where do you want to go? Okay, I will give you an example. Okay, I'll give you a very simple example. You will understand what is this routing table in a very easy way. You can see. Now, this is my topology. This is the topology diagram I'm taking. I'm going to take a topology diagram. Okay, like this. Okay, so this is my home, my house, okay, which is available in souk. Okay, for example. Now, this is the first roundabout. This is the first roundabout in sur, so I make it R, router. Then, this is the second roundabout. Then, this is the next roundabout. Then, this is the next roundabout. This is the next roundabout. This is the next roundabout. And this roundabout, it is going somewhere like this. Okay, we don't know where it is going. And this is the last network, and I'm going to say this is Muscat. Okay, so this is Muscat. Now I am in Sur. I am in Sur. Now what I'm going to do means I'm going to take my car. Okay, I'm taking my car. So my car, it is the packet. That is a data packet. So I take my car. So in the car, it is written from where you are coming. I am coming from Sur. Where do you want to go? I want to go to Muscat. Okay, you can use the IP address. For Muscat, there is IP address available. For Sur, there is IP address. So from where I'm coming from Sur. So where I want to go means I want to go to Muscat. Okay. Now my car is coming. I'm going to the first roundabout. Okay, I'm going to the first roundabout. Now in the first roundabout, okay, there is a police. A policeman is going to stand. Okay, a policeman is going to stand here. Now the policeman is asking, where do you want to go? Where do you want to go? So this policeman is the routing protocol. The policeman is the routing protocol. Okay, he is the routing protocol. Now he is asking, where do you want to go? Now I'm telling, I want to go to Muscat. I want to go to Muscat. Now this policeman is going to have a table, okay, a paper. He is going to check in the paper. This is the routing table. He is going to check it in the paper. So to Muscat, what is the path? Now he is going to decide from this paper. Is taking and is telling, okay, you go straight in the roundabout. He is forwarding me. Okay, you go straight. Now I started driving. I'm coming to the next roundabout. The packet is coming to the next roundabout. Same, in the next roundabout also, there is a routing protocol. That means the policeman is available here. Routing protocol. Now the policeman is asking, where do you want to go? Okay, I'm telling, I want to go to Muscat. Okay, now the policeman here also, he is going to have a table. Okay, a paper he is having. He is checking the path, how to go to Muscat. He is checking the path. Now he is telling, okay, you straight, go straight. He is simply forwarding me, okay, you go straight. Now, so in this roundabout also, I'm going to maintain straight. Then I reach this roundabout, the third roundabout. Now, here also you are having a routing protocol. That means the policeman is available. So now the policeman is asking, where do you want to go? Now I'm telling, I want to go to Muscat. Okay, wait. Now this policeman is going to take the table, that is a routing table. He is checking the routing table. Then he is telling, if you want to go to Muscat, okay, you can take left. Okay, go left. He is giving the instructions, go to left. Okay, go to left. Now my packet is moving. I'm moving to the next. Take right. This is called routing protocol. So in every router, you will be having routing protocol. The routing protocol will give, it will forward, it will take some decision, then it will forward you. Okay, it will forward you either left or right or straight, okay, whatever it is. So every routing table is going to have every router is going to have a routing table. Routing table, routing protocol. The routing protocol is going to maintain a routing table inside the router. Okay, inside the router. So this is the concept of routing tables. Now you can see in the previous one, you can see this is the routing table of one router. Okay, so the routing table of one router, and this is the routing table of the another router. So for every router, there will be a routing table. Okay, so this is the concept. Okay, now I'm moving to the next one. The next one, you can see this. So in this topology diagram, this is also a topology diagram. Here, what they are doing, see, N2, this is network 2, this is network 1. And then this is the router, R1. So for R1, okay, you will have a routing table here. Okay, so every router, it is going to maintain a routing table. Okay, every router, it is going to maintain a routing table. Okay, now, if you take the routing table, there are two different ways. They are maintaining the routing table in two different ways. So what does that means? The first one is called host, okay, host specific method, network specific method. Okay, what is this host specific method means? Okay, you see here for A, B, C, D. About all these things, okay, in my routing table, this is the route. Okay, for example, this is the routing table of R1. Okay, the routing table of R1, it is available here. So routing table of R1. Now I'm going for host specific. What is host specific means? About every host. Okay, that means A. For to go to A, how to go? I'm going to write. To reach the host B, okay, how to go? Okay, there is a path. For to reach the host C. So if you want to go to A, go to router 1. If you want to go to the host B, you must go to router 1. If you want to go to host C, you have to go to router 1. If you want to reach D, you have to go to router 1. So I am in this machine. From here, if I want to go to A, I have to go to router 1. If I want to go to B, router 1. Router, okay, this is called host specific. Each and everything, every host will be available. This is not a good method. This is not a good method because number of hosts will be more. You will be having thousands, hundreds, millions of hosts. You cannot manage like this. So instead of that, you can go for network specific method. Okay, so what is network specific method means? All they are in same network, everybody in same network. Okay, A, B, C, D. So I'm going for network N2. Okay, only the network I'm giving. Okay, so that means if you want to give specific, okay, I'll give you a specific example. 10.0.0.1, this is the first host. 10.0.0.2, this is the second host. 10.0.0.3, this is the third host. So you can have like this. This is called host specific. What is network specific means? All these things I'm going to write like this: 10.0.0.0. Finished. Everything is available inside this network. So this is called the network specific and this is called the host specific. So 10 network, if I say 10 network, everybody is available in that. 10.1, 10.2, 10.3, 10.4, 10. Everybody in that. Okay. So routing table, there are two different methods available. So first method is a host specific method. The second specific method is a network specific, but network specific is common. Okay. We are not using the host specific. This method we are not using. Okay, so the host specific method, okay, it is completely not used. Okay, because the routing table will become very big. You will have a very big routing table here. So go for the network specific. This is. Now, I'm going for the next slide. You can see the another one. Host specific routing. So host specific means you have to talk about every host. Okay, see, this is the routing table of A. Okay, let me just maximize it so that you can understand. See. Now you can see in this topology diagram, I'm in host A. Okay, I'm in host A. Now this is the network. Okay, network one. Okay, totally how many networks available means three networks. Okay, this is one network, second network, and third network. Now I'm going for the host specific routing table. Okay, so for host A, I'm writing the table. What does that means? From here to all the host B, network 2, network 3. Okay, so everything I'm writing. If I want to go to host B, I have to go to the router 3. So from here, I want to go to this person. I want to reach the host B means I want to go to the router 3. Yes, I want to go to the router 3. So from the router 3, I can reach this. Okay, reach this machine. Then, if I want to go to N2, N2 means this is network 2. I want to go through R1. Yes, this is the route. This is the route. Then, if I want to go to N3, I want to go to R3 through R3. That means from this machine, I can go like this. This is called the routing table. So the routing table will give you a clear information. It will give you the different types of paths. Okay, what are all the different paths? It will give it. Now, I'm going for the next one. The next one is called default route. Okay, what is default route means? In default route, okay, we are not going to give the network. Okay, for example, yesterday what we have done in our lab, okay, we went to the static. Okay, I'm writing the steps here so that you can understand very easily. Okay, in the yesterday class, okay, you go to the router. So in the router, you can go to the config. In config, okay, so you will have a option called routing option. Under the routing options, you have a feature called static. Okay, we have done this yesterday. So you click the static. Now, in static, there are three different options, three different things we have given. What is that means? Network. We gave the network. Okay, we gave the network. Then we gave the mask, subnet mask. Then we gave the destination. That means hop. So we gave these three things yesterday. Okay, if you see the video for creating the static route. Okay, if you want, I will share you a packet tracer. Just 1 minute. I'll share the packet tracer. So I take a PC here. Okay, I'm taking a PC here. Then I'm going to have a router. Look at the diagram carefully. There's a router. Then I'm going to have one more router. Then I'm going to have one more router. So I keep three routers here. Okay, I'm keeping three routers here. Then I'm going to have a PC. Okay, I make the connections like this from here to here. Then I'm going to connect here. So I make the connections like this. Okay, so this is the connection. Now I want to send the packet from PC 0 to PC 1. Okay, I want to send the packet. Now, first thing, we are going to fix the IP address. Okay, I'm going to show two things to you in this. One is routing table. I want to show you the routing table. Then I want to show you, okay, the default routing. Okay, default routing. Yesterday we discussed about static routing. Then we discussed about dynamic routing. We discussed in dynamic routing. We discussed about the RIP protocol. This is yesterday we have done. Okay, so today I want to show you the routing table and the default routing. Okay, how to do it. Everything we can do it in the same lab, no problem. Now I'm going for the IP address for this machine. 10.0.0.1 is IP address. And here I'm going to give 10.0.0.2 is IP address. Then this is the next network. Router to router is the next network. So here I'm going to make 20.0.0.1 and here I'm going to make 20.0.0.2. Okay, so this is 20.0.0.2 and this is 20.0.0.1 and here 10.2. Then this is also a network. This is also a network, but we don't have any host here, but it is a network. So now here I want to give 30.0.0.1. Then here 30.0.0.2. Okay, so this is the IP address I want to fix. Then the last one for PC1, I want to give the IP address 40.0.0.1. Then here I want to give 40.0.0.2. Okay, so these are all the IP address I want to fix. Okay, I want to fix. So now I want to configure the IP address. Okay, I want to configure the IP address. So how to configure the IP address means already we know. Yesterday we discussed about it. So go to PC0. So desktop IP configuration. So the IP address is 10.0.0.1. Okay, 1. Subnet mask 255.0.0.0. So default gateway means the IP address of your router. Okay, so 10.0.0.2 is the IP address. Okay, so I close this. Then here, this is fast Ethernet 0 by 0. So if you keep your mouse, okay, it will tell. This is fast Ethernet 0 by 0. Okay, fast Ethernet 0. Click the router. Okay, click the router. Go to the config. Okay, go to fast Ethernet 0 by 0. So IP address is 10.0.0.2. Subnet mask, then port status on. Okay, so this is there. I'm going for the next. So the next interface, you can keep your mouse here. So it is giving the instruction serial 2 by 0. Serial 2 by 0 with clock rate. So yesterday we discussed about this. So with clock rate. Now I go to the router. Serial 2 by 0. So the IP address I want to give 20.0.0.1 is IP address. Subnet mask. Okay, the clock rate is 64,000 is the default clock rate. Make port status on. Okay, so you can close this. So we fix this IP address. Next one. So next one is serial 2 by 0. If you keep your mouse, okay, it will give you the hint. Serial 2 by 0. So click the router, go to config, serial 2 by 0. So the IP address is 20.0.0.2 is IP address, subnet mask, make port status on. So now we completed this. Then I'm going for the next network. So here serial 3 by 0, serial 3 by 0 clock rate. So go to serial 3 by 0. So IP address is 30.0.0.1 subnet mask with clock rate. So clock rate is 64,000 is the clock rate. Make port status on. Okay, then you can close it. Then the next interface serial 2 by 0. Okay, serial 2 by 0. Okay, now I just click here, go to the config. Okay, serial 2 by 0. Yeah, go to serial 2 by 0. IP address is 30.0.0.2 is the IP address. Subnet mask, port status on. So now I completed up to this. Then the next one is 40.0.0.2. So this is fast Ethernet 0 by 0. So click the router, go to fast Ethernet 0 by 0 interface. So IP address is, okay, what is IP address means 40.0.0.2. Then 255.0.0.0. So make port status on. Then go to the last one, the PC. Go to the desktop, IP configuration. So static 40.0.0.1 is IP address, subnet mask. Here you have to fix a gateway. So gateway is the IP address of your router. So 40.0.0.2 is a default gateway. So now I'm just closing this. So your topology diagram is ready. Okay, your topology diagram is ready. Now I go to the router. Please note down. Please note down. Yesterday we didn't. Okay, I didn't give this to you. Please note down. Go to the CLI command line interface. So I'm somewhere, I don't know where I am. I'm just giving exit. You can give exit, 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 come out from that. Yes. Now you are inside the router. The first command is enable. Okay, you can give the command enable. So what is enable and all? Okay, you will learn it in the next semester. You don't need to worry about it. I'm just giving enable. After enable, I'm going to give the command show IP root. This is the command. Show IP root. Please note down. Show IP root. Okay. So this command will display the routing table. I'm seeing the routing table of R0. So if I enter, you can see, okay, starting from here to here, it is routing table. Okay, this is the routing table. Okay, what is the command? I type the command again, show IP root. Show IP root. Okay, that is the command. Okay, displaying the routing table. Now, in the routing table, you can see there are two lines available. What are the two things available in the routing table means, see, 10 network 10.0.0.0/8 means that is a subnet mask, CIDR value. Okay, that is called the CIDR value. So 10 network and 20 networks, both these networks are directly connected. Yes, that means here 10 network is directly connected, here 20 network is directly connected. So 10 network and 20 networks directly connected in this router. If you go to the next router and if you give the show IP root, you will find 20 network, 30 network directly connected. Okay, I will show that. So go to the next router. In the next router, I'm going to the CLI. So we are somewhere, we don't know where. So just you can give exit. Okay, you can come out. Now the first command is enable. Okay, after enable, I'm giving the command show IP root. Show IP root. Now you can see the routing table. In the routing table, so what is available means you can see the routing table. So 20 network is directly connected, 30 network is directly connected. So here 20 network, this side 30 network is directly connected. Same thing. If you go to this router, you will find 30 network is directly connected, 40 network is directly connected. Now I'm going to take my car. Okay, I'm going to take my car from here. Okay, go to our example. So from this, okay, I'm going to move. I want to move to this place. Okay, or I want to go to Muscat. This is Muscat. Okay, take it like this. So this is Sur. I'm in Sur now. So from Sur, I want to go to Muscat. Okay, I want to go to Muscat. So now what I'm doing, I'm going to take my car here. I'm going to move. So I'm coming to the roundabout. So in the roundabout, I'm going to ask, or the roundabout, okay, the policeman, routing protocol, okay, routing protocol, or the policeman, okay, he is going to ask, where do you want to go? Okay, where do you want to go? Now, I'm telling, I want to go to Muscat. That means I want to go to 40. Okay, I want to go to 40. Now, this policeman is going to the routing table. He's going to take the routing table, show IP root. He's taking the routing table. In the routing table, he is checking 40 is available. Okay, 10, 20. But you are asking, I want to go to 40. So 10, only 20 is there. I don't have the information about 40. So I cannot guide you. You go back. Error. Okay, you go back. I don't have anything. Okay, I cannot guide you because in my routing table, only 10 is available, only 20 is available, but you are asking for 40. So I don't know where is 40 available. Okay, you can go back. So automatically your packet will come back. So in this routing table is not complete now. It is not full table. Only 10 and 20 is available. There is no 30, no 40 here. So if you are asking, I want to go to Muscat means this person cannot help you. He cannot help you. So we are going to create a static root. We are creating a static root. We have done yesterday this. Okay, but anyway, I will do it again. I'm going to create a static root. So how to create the static root? I go to the static. Then I'm going to type the network. What is the network means? 40 network. If I want to go to 40 network, then what is the subnet mask? 255.0.0.0. So the next hop, what is the next hop means? The next hop is okay 20.0.0.2. So 20.0.0.2 is the next hop. Okay, 20.0.0.2 is the next hop. Okay, I'm going to add it. Okay, I'm going to add it. Now you can see the routing table. Go and see the routing table now. Okay, go to the CLI. Go to the CLI. Now you can just give exit. Okay, exit. So I'm giving enable. Now I give the command show IP root. Okay, I'm giving the command show IP root. Now you can see the routing table. In routing table now, okay, it is added. So before 10 is directly connected, 20 is directly connected. But now I created a root, static root, yes. So what is yes means? You can see here. So yes stands for static. Yes means static. C means directly connected. C means connected. Okay, if I use a RIP protocol, you will get R, RIP protocol. So this is directly connected. 10 is directly connected. 20 is directly connected. Okay, then we created a static root for 40. We created a static root for 40. So to go to 40, it will go to 20.0.0.2. So 20.0.0.2 means this is. Okay, so now what I'm doing, I'm taking my car, okay, from Sur, I'm coming to the roundabout, first roundabout. So in the first roundabout, okay, the router is asking, where do you want to go? Now I'm telling, I want to go to 40 network, Muscat. Now they are telling, wait. So take the routing table and they are going to check in the routing table. 40 is available? Yes. So if you want to go to 40, you go to 20.2. So now it is sending my packet. This is called forwarding. It is forwarding my packet to 20.2. Now I go to 20.2. In 20.2, okay, again they're asking, where do you want to go? I want to go to 40. Wait. So this router now R1 is going to take the routing table. So in R1, okay, only two lines, only 20 and 30 is available. 40 network is not available. Your packet will be dropped here. Okay, your packet will be dropped here. So if you want to check, you can go to the simulator, go to the edit filters, ICMP. Okay, take only the ICMP protocol. Now I'm going to give the ping command. You can see your router, your packet will be stopped here. Okay, because there is no 40 here. So I give PC0 to PC1 and I'm giving the auto capture. Okay, now you can see your packet. You are taking your car. You are going to the first roundabout. They're asking, where do you want to go? I want to go to 40. Checking in the routing table. Yes, 40 is available. You are now forwarded to 20.2. But here, okay, they're asking, where do you want to go? I want to go to me. 40 means here there is no 40 information. So your packet is dropped in this place. Okay, your packet is dropped in this place and they will give you a error message. Okay, a error will come. The red color is the error. Okay, if you give it again, okay, I just delete it. I repeat the same step. Now you can see it will give you a error message. A error message will come back to you. So this is the concept of, okay, routing table. So every router will have a routing table. Okay, it will have a routing table. So you are getting the error message. So if you see in this machine, you will get the error, destination host unreachable. Destination host is unreachable, you cannot reach. So now what I'm doing, I go to the real time. I'm going to create static root here. So this is what we discussed yesterday, but now my concept is I don't want to create static route. I want to create something called default route. What is default route? Default route means, okay, the people, those who are very lazy, the people, those who are very lazy will create the default route. What is this, teacher? What is lazy? Okay, nothing. See, okay, see, a person is coming, okay, a packet is coming or a car is coming to this. It is asking, okay, where do you want to go? I want to go to 40. Now I just close my eyes and I'm going to tell, okay, go in this way. Okay, I'm not asking where do you want to go. Okay, you go anywhere. You go to Muscat or you go to Nizwa. Okay, anywhere. Okay, it is not. I'm not going to worry about it. Okay, your destination can be anything. You go to 10 network, 20 network, 30 network, 40 network. No problem. I will simply send you in this. This is called default. Okay, now I'm going to create a default. Okay, routing here. See, I go to the config. I'm going for the static. Okay, already we have. Okay, already we have. I remove this. Okay, already we created for 40. I'm going to remove it. So there is no static routing now. I'm going to create a default routing. So default routing means 0.0.0.0. What is this 0.0.0.0, teacher? This is called any network. 0.0.0.0 is called any network. You can go anywhere. Okay, you can go anywhere. I'm not going to worry about where do you want to go. So any network 255.0.0.0, or this is also I'm going to make it 0.0.0.0. This is very safe. A very safe method of creating the route. Okay, you are not going to worry about the destination, anybody. So the next hop is, okay, I'm going to forward here. I just make it add. So this is called default route. Then I'm going for the next person here. I'm going to the config. I go to the static. Here also I'm going to create a default route 0.0.0.0. Then subnet mask 0.0.0.0. What is the next hop? The next hop is I'm going to forward them to 30.2. So now you can see 30.0.0.2. Then I can add it. Okay, so the next router, we no need to add it. Okay, only in this two router is enough. Now you see routing table. I'll show the routing table of any router. Okay, you can see the routing table now. Show IP route. This is the command for routing table to display the routing table. Now you can see 20 is directly connected, 30 is directly connected. Okay, I am in router 1. Then 0.0.0.0. This is the default route. So default route, is it safe? Means no, it is not safe. Anybody can enter into your network. Okay, anybody can enter into your network. Okay, it is a risky one. Okay, it is a risky one. But anyway, now I'm going to give a ping command from PC0 to PC1. Okay, I'm going to give the ping command. So automatically you can see. Okay, you can see whether it is reaching or not. I just give the ping command from PC0 to PC1. I give auto capture. So I'm coming to the first roundabout. Here default route. If anybody coming, forward. Then here also default route. I'm not checking where are you going. Default route, forward it. Then so here automatically here they will ask where do you want to go. Okay, this first time you can just delete it and you can give the command again, the ping command. First time you will get that error. Now, so this is the default route. Second time if it is not working, then you have to check. So here it is a default route. Here also it is a default route. I created a default route up to this. Now I reach the 40. Okay, I reach the 40 network. So completely 40 reach. Now you see the return. Okay, you see the return. Okay, so the return is the problem. Why return is the problem? Because from here, while going back, they're asking, where do you want to go? I want to go to SUR. I want to go to 10 network. Now, this person is checking in the routing table only 30 and 40 is available, 10 is not available. Okay, 10 is not available. So you have to create a default route here. So from here to here, a default route. From here to here, a default route. If you create, automatically your packet will go and come. Okay, so now I go to the router 2. So in the router 2, now I'm going to create a default route. So go to the static. I'm going to create a default route 0.0.0.0. Subnet mask is 0.0.0.0. So the next hop, what is the next hop means? From here to 30, 30.1. So 30.0.0.1. Okay, I'm just going to add it. So your packet will come up to this, up to 30.1. So here they will drop. Now I'm going to create one more default route here to come back. Okay, that means the return. So here I'm going to the static. So already there is one default route available for left to right. This is right to left to move the packet from right to left. So 0.0.0.0 subnet mask 0.0.0.0. So now you can see the next hop. The next hop is 20.0.0.1. Okay, so this is the next hop. So you can forward it. Now you can see there are two default routes available in this router. Okay, I will show the routing table. Okay, go to the CLI. You can see the routing table now. There will be 4 lines. Show IP route. If I give show IP route, there are 2 things available. Okay, see, directly connected. 20 is directly connected. Yes, 20 is directly connected. 30 is directly connected. Then we have 2 default routes, one for 30.2, one for 20.1. So that means from here to here, 20.1, there is one default route. From here to here, 30.2, okay, there is one default route. So there are 2 default routes available in this topology diagram. Okay, sorry, in this router. So now if you give the ping command, automatically your packet will go and it will come back. Everything only in the default route. Okay, yesterday we discussed about the static route. In static route, we have to give the destination, but here you no need to give the destination, simply 000. But this is not a advisable method. Okay, it is not a very good method, but this is also available. You can see anybody can go. Anybody can go in your okay routers. So this is the concept. Okay, just to give it again. Okay, just delete it and give it, because first time you will have this problem. So automatically you will reach. Okay, the packet will reach the destination, then you will get the reply. Yes. Somebody else? Tell me.
If I have two ways to go to the BC2.
No, you have to mention. You are going to mention the next hop. The next hop you are going to mention. Okay, see 0.0.0.0, that is a network, but what is the next hop you are going to mention? So automatically in that path only it will go. You will mention, okay, where, okay, you are asking, suppose I have two paths here, am I right?
Yes.
Yes, suppose, okay, I understand what is your question. Okay, I will answer it. See, I'm going for the real time. Okay, suppose if I have a router here, if I have a router here, okay, if I have a router here, so what it will do means you are mentioning here what is your next jump. You are mentioning, no, you are mentioning, you are clearly you are mentioning the jump. So automatically okay, only for the jump, the next hop it will go 0.0.0.0, then 0.0.0.0, but the next jump where you want to make, so that is you are going to fix, the administrator is going to fix. So even if you have many paths, so you fix the path, in that path only it will move. Okay, in the particular path.
I mean, if I have another row, another way to go to the BC2.
Another way to go to. Repeat your question, please.
Like yesterday.
Like yesterday. Yes, same. Yesterday you mentioned the destination IP address. But here you are not going to mention the destination IP address, but you have to mention the next hop. You have to mention the next hop. Next hop is common, everybody, everywhere, either static or either static or default. You have to mention the next hop, no doubt. But only the destination network you are not going to mention. Okay, only the destination you are not going to mention here. So the destination is going to be 00. This is very safe method, very easy method. So you no need to worry about what is IP address, anything. Simply you are making 00000000 any network. But this is not a very good method. Okay, so this is the thing I want to show you to you. I'm going for the slides. So in the slides, okay, you can understand better now. Now I'm just going to, yes, we are in default routing. So the default routing, you will give everything zeros. 0.0.0.0. So this is about the default routing concept. Okay, so I have done this by using a simple lab, a very simple lab we have done, and we discussed about this. Now, simplified forwarding module in the classless addresses. Okay, now classless. What is classless? What is classful? Okay, you must know the difference between the classless and classful. So classful means no subnetting. Okay, no subnetting. You have not done any subnetting. Okay, you have not done any subnetting. That is called the classful IP address. So what is classless IP address means you have done any subnetting. That means your subnet mask will change. So for both, you can do for both, okay, whatever it is, for both, okay, it is a classless IP address or classful IP address. For both, we can do the same, okay, we can do the same thing, okay, you can see this, the packet is coming, okay, your packet is coming. You are going to take the destination IP address. What is the destination IP address? Then it is going to search it in the table. This is the routing table. Okay, it is going to search. The routers is going to search in the routing table. Now, from the routing table, they are taking the decision. Okay, it takes the decision. Then the packet will be forwarded to the next router. So it will be forwarded to the next interface. Okay, so this is the concept, how it is working. So a packet is my car. I'm taking my car. I'm coming to the roundabout. Okay, that is called the forwarding module, or we can say it is a roundabout, or we can say it is a router. Technically, it is router. Now, the router is asking, where do you want to go? That is my destination. I want to go to 40 network. Then please wait. Let me search in my table. So it is going to search in the table, in the routing table. So in the routing table, it is very clearly given. Okay, if you want to go to 40, what you have to do? That is called the next hop. Now, okay, they are taking from the routing table, they are taking the decision. Then I will be forwarded. Okay, it is giving the instruction. You go straight or you take right, you take left in the roundabout. So automatically you are going to the next roundabout. Okay, that means the next router. Okay, so this is going on like this. So this is what I explained by using the packet tracer software. Then unicast routing protocols. So what are all the different methods available? Different methods. Yesterday class we discussed, today also we discussed. So there are two different methods available. One is called the static method and second one is called the dynamic method. So if you go for the static method, okay, you have to enter everything manually, you have to create. So the administrator will create the path. The administrator has to go to the routers. Every router, you have to log in into the router and you have to fix your own path manually, you have to create. But if it is a dynamic routing table, if it is a dynamic method means you will use some protocols. What is that protocols means? They are called the routing protocols. Okay, you are going to use the routing protocols. The routing protocols, they will do everything. Okay, they will do automatically everything. You no need to do anything. So automatically the dynamic routing protocols, they will take care of it. So the routing protocols, they will create the routing table, they will manage the routing table. So everything they will do automatically. So if there is any problem in your network, that means in your topology diagram, one network, okay, goes down. Once one router is not working, everything the routing protocols will understand. Okay, routing protocols are very clever. So they will understand everything. So based on that, okay, they will change the route. Yesterday we discussed. Yesterday what we have done, we made one switch off. Sorry, one router we switched off power. We cut the power, electricity. Then automatically it is taking the another path. Okay, automatically it is taking the another path. So this is okay. The routing protocols are dynamic. They are doing everything automatically. Okay, so this is the concept. Then, if you are going for the routing protocols, so the routing protocols they will maintain. Okay, they will maintain. Okay, you can see there is an example given here. So what is this means? This is the source and this is my destination. So S1 is my source, S2 is the destination. They will select the best path for you, shortest path. We have discussed this yesterday. Okay, so it is going to find the best path, okay, the optimum path, or we can say it is the best path it will find. So now you see from S1 to okay D1, there are many paths available. This is the first path, and this is the second one, the second path. Okay, there are two paths available here. Okay, there are two paths available. So I will just, okay, I will mark down. You can see this is the first path, path number 1. Okay, I made it in the yellow color. And there is one more path available. So this is the next path. Okay, this is the next path. Now there are two paths available. So in this, which path will be the best? Which path will be the best path? That is called the optimum path. So the optimum path it will decide. Yesterday we saw in our lab part. Okay, we saw that. So there are two different paths available. It will take only the shortest path it will take. So this is the use of routing protocols. So routing protocols are very talented. That means very what to say, very effective one. Okay, it will take the decisions. Okay, lot of decisions it will take. There. The next concept is autonomous systems. So what do you mean by autonomous system? Means group of routers. Group of routers. You can make a group of routers, okay? 5 routers, 10 routers, 20 routers. I'm going to put it in a group. So they are called autonomous system. Okay, you can see. Autonomous system means a domain, okay, is a set of routers. A set of routers or networks administered by a single organization. Now what is that means? You take, this is Oman. All the routers in the Oman, okay, I'm going to make it as a autonomous system, and this will be managed by Omantel. So this is the autonomous system, group of routers available in some other country. Okay, take it India, and this is Oman. So they are going to connect it. So two things will be connected. Then only you can send and receive the packet. Okay, so what is the concept of autonomous system means? Autonomous system is nothing. It is a group of routers, a collection of routers. Okay, a collection of routers. So many routers you will put together, you can add together. That is going to be the autonomous system. Okay, why? What is the reason? We will discuss it in the coming. You will study this later. In the next course, you will study about this. So here, simply, what is autonomous system? Only we are giving. There. The next one, intra-domain and inter-domain routing. Okay, that is interior routing and exterior routing. Okay, I go to the previous slide. Now you can see I take the first autonomous system. So first autonomous system means this is one group. So you can do routing inside this. Inside this, you can send and receive the packet. That means from the first router to the second router or first router to the third router. So you can do it inside a group. This is called inter-domain routing. That means I'm what we are doing now from my machine. I'm talking to your, okay, you are receiving the data. So we are now doing inter-domain data transfer. We are sitting inside Oman and we are doing. The same thing we can do it intra-domain. Intra-domain means, okay, I'm in this machine. Okay, I'm going to sit in this autonomous system, okay, in any one machine, and you are going to sit in a different country in a different autonomous system. Now, so from here to here, you can send the data. Okay, this is called intra-domain, inter-domain. Okay, you can see in the next slide. So intra-domain and inter-domain. So intra means in the same network, inter means different autonomous system. Okay, so routing between autonomous systems, it is referred as inter-domain. Routing inside an autonomous system, inside an autonomous system, it is called intra-domain. What is autonomous system? Autonomous system means a group of networks or routers under a single administration, a single administrator. I gave the example as Omantel. So Omantel is going to be the administrator of all the routers in Oman. Okay, so this is called the autonomous system. Now, I'm moving to the next one. This is just okay, simple concepts only. Now, I'm going for the next one. You can see the routing protocols. We are dividing into two routing protocols. Okay, yesterday we discussed one routing protocol. What is that means? That is RIP. RIP protocol we discussed. We enabled the RIP protocol. Okay, so RIP protocol, yesterday we enabled the RIP protocol. So routing protocols, we are dividing into two groups. There are two different groups. What are the two groups? Routing protocol which can be used, okay, that means intra-domain and inter-domain. So intra-domain means within the group, within the autonomous system. You can use within that autonomous system, you can take. So this is one autonomous system means, so within the autonomous system, we can use one routing protocol, okay, that is called intra-domain. So this intra-domain, again, we are dividing into two things, into two groups. The first group is called distance vector and second group is called link state. Okay, in the next course, that means in the introduction to routing and switching, there is a course available. You will study about, okay, this distance vector routing protocol, about this one lecture, and about this link state, you will study 3 lectures you will study. Okay, so totally there will be 4 lectures for routing protocol. Okay, you will study about this. So routing protocols, we are dividing into two groups. The first group is intra-domain. The second group is inter-domain. So intra-domain, we are dividing into two groups. One is the distance vector and link state. For distance vector, okay, don't ask me the question, what is distance vector? It's a big thing. Okay, so we are not going to cover here. So the next course we are going to cover. So distance vector, the example is RIP protocol, RIP. So RIP means routing information protocol. Routing information protocol, RIP protocol. Okay, not only RIP, there are so many protocols available. For link state also, we are having so many examples. Okay, so link state routing protocol, the example is OSPF. Okay, OSPF protocol, open shortest path first. Open shortest path first. Okay, that is the OSPF protocol. Then the next protocol is, okay, for intra-domain, it is path vector. Path vector is a type. For path vector, the example is BGP. So BGP means border gateway protocol. Okay, border gateway protocol. So these are all different types of protocols available. So RIP we used in the yesterday lab. Okay, we configured the RIP protocol. Then the next one is routing algorithms classification. So this is already we have completed in the previous slide. So we are dividing this into two groups. So the first group is called distance vector and the second group is called link state. Okay, distance vector and link state. Okay, what is distance vector? They are giving in a very small paragraph. So what is a distance vector means? Okay, you see distance and vector. Distance and vector. Okay, what is that? See, this is the router, this is the next router, and this is the next router, next router. Now, I'm here, I'm in this place. I want to go to Muscat. So Muscat is available here. Now, according to distance vector, I'm going to tell, okay, you have to go straight. This is the, okay, vector. Vector means a direction. So you have to go straight, then you have to go straight, then you have to go straight. Okay, this is the vector. and you have to go straight. So the distance, sorry, this is the vector. Vector means direction. Straight, 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 straight. Then, what is the distance? Distance means this is, you have to make one jump, one roundabout. If you cross, this is one. And second roundabout, if you jump, this is, okay, the second, number two. And you make another jump, okay, you will reach Muscat. So that means, so the direction is straight, okay, you have to cross three roundabouts. This is called distance vector. So distance means how many number of routers you have to cross. Then what is the vector means? What is the direction your packet is going to move? This is called the distance vector. What is the link state algorithm, or the what is link state means? The link state is, okay, it is not going to count the jump, it is going to count something, okay, the link cost, okay, you see the cost. So what is the cost? I'm going to say from here to here, okay, from first roundabout to the second roundabout, okay, I'm going to say it is 100 kilometers. From second roundabout to the third roundabout, from the second roundabout to the third roundabout, it is going to be, okay, 50 kilometers. Then from this roundabout to this roundabout, okay, it is going to be 60 kilometers. Now, okay, in the link state routing protocol, okay, how I will tell means, I'm going to tell 100 plus 50 plus 60. So 200 kilometers I want to travel. This is called link state. Okay, so if anybody is asking me how to go to Muscat from Sur, you can answer in two different ways. You can answer in two different ways. I can answer like this. So please keep on going. Okay, straight, straight, straight. If you cross three roundabouts, you will reach Muscat. So first roundabout in Sur, second roundabout in Kuriat, third roundabout in Amirat. So the fourth roundabout, you will reach Muscat. Okay, you will reach Muscat. This is called distance vector routing protocol. So the distance vector routing protocol will always see how many routers you have to cross. But link state routing protocol is not like that. Link state routing protocol, it is going to see, okay, the cost, the link cost, it is going to see. Okay, the link cost, it is going to see. So that means, so from here to Muscat, how to go? You have to go 200 kilometers from here, or 210 kilometers from here. Okay, this is the next method. So every method, it is having its own way of calculating. Okay, the own way of computations or the own way of calculations it will do. Okay, so here the link cost, and here it is going to be the number of roundabout, that is called the hops. How many hops you have to make, and then the direction. Okay, direction. If you ask me which is best, distance vector is the best or link state is the best, means link state is the best. Okay, distance vector, it is not, okay, going to be a very effective one, but it is basic. Okay, it is a basic routing protocol, but the link state routing protocol is a very strong routing protocol. Okay, you will study this with, okay, in the next semester you will study about this. So this is a small introduction. Okay, you can, what we discussed means in this lecture. So we discussed about the packet delivery methods. Then we discussed about the next hop method. Okay, then we discussed about the autonomous systems. Then routing protocols. There are two different types of routing protocols: interior and exterior routing protocols. That means RIP protocol. Okay, there is a flow. Okay, there is a diagram here. Okay, this is very important. So routing protocols, intra-domain, inter-domain. So in the intra-domain, we are having the distance vector and link state, and inter-domain, we are having the path vector. So this is a very important concept. Okay, as far as this lecture is concerned. Okay, this is a very small lecture only. So with this, okay, so we are completing lecture number 13. So please kindly practice, okay, for your next lab exam. It is going to be in the routing.